Hi, in this demo, I'm going to show you how you can use the extracted ODE data in an Excel format and to be able to import them into SPSS and to analyze this second-hand data for decision-making purposes. So we know we saved our data from ODE into our thumb drive, so in Excel format, but I wanted to work in SPSS. So first of all, I have to go to Virtual Lab and get into your SPSS spreadsheet like this, and I can go to File, Open Data, and I remember we saved our data in the thumb drive, so removable E drive here. And remember, we are looking in the E drive, but we are looking for the data type in Excel format. So the file of type is Excel format. And there we saved the school district level data, building level data 2012 and 2013 with a desegregated economic status. So if I'm clicking on that, and you can notice that the SPSS is reading Excel file into its own spreadsheet, and it's reading it, opening Excel file resources. So you say OK. You will be able to see the data has already been imported from Excel into SPSS like this. So the first thing you need to do is just to save it right away into your thumb drive here. You can save it as the same way as 1213 LRE building economic data, but at this time it is not Excel XLS data, but it's SAV data. So you can just say the same name, but it's in SPSS file, so you can save, so you can use next time. And also, when the data sheet is like this, again, you have to be able to identify in our economic status data, we know it's a string, it's fine. But we have this test score data, reading third grade, math third grade, reading fourth, and math fourth grade. So we have the score data, and we know they're not in string, they're not categorical, but continuous. So in this case, if you highlight the data type here, there's a box here. So now you are going to change the string type into numeric type. So there's numeric here, so you click on numeric. So the data type is changed from string to numeric. You say OK. So it's being changed. Again, the string, you click on the box here. So right now it's string, but you want it to be numeric because it's a continuous variable. So you hit on OK. Another way to do it is to click, right mouse click, and say copy. Since these are all going to be continuous in numeric format, so you can copy the numeric and paste it. So the whole data type is changed from scale, from ratio, from a continuous variable instead of nominal variable. And also for that purpose, you wanted to, since this is a continuous variable, you might want your decimals to be changed to be changed not 0, but maybe 2 decimals. So you click on here. This is a 0, the decimals. You can click up 1, 2. So you can go here and click on up 1 and up 2. So these means your scale is in 2 decimals instead of 0, no decimals. And after you treat that, you want to save it again. So next time you use it, it's the same thing. And then we can conduct some statistical analysis. For example, we can go to Analyze, to do descriptive statistics for frequency. And in frequency, we can only do categorical variables. The categorical variables here we have would be the economic status, or maybe school type, if you wanted to do that. So we can look at the frequency mode of the categorical variables. If we hit OK, you will see the categories include 3,546 disadvantaged and 546 non-disadvantaged participants. It's 50-50, and we have different school types. We have community schools conversions, we have community school startup, we have dropout recovery, we have elementary, high school, junior high school, middle school, STEM school, and ungraded school, and we have frequency and percentage of the school types. So if we wanted to look at the disadvantage and if we wanted to look at the categorical variables with the student performance interaction, then we can go to analyze and we can go to compare means. So we can look at the means across the categories. So I'm going to do a mean here, and for example, if I'm interested in comparing the advantages versus the non-advantaged social-economic status school performance, I can click on economic status and put it into the independent list, and I can put the, let's say I'm going to compare the 6th grade reading, 6th grade math with economic status. So in here I can go to option, where in the cell statistics I will have mean of each group, I have number of cases, I have standard deviation. So maybe I wanted to have minimum and maximum. And if you are interested, you can also put in something like skewnesses into it as well for this, to look at the data distribution. So maybe these are the things I'm interested in looking at. I can hit on continue. Okay. And here I have a table of reporting of 6th grade 2012 and 2013 performances of 6th grade math and reading in terms of disadvantaged group and a non-disadvantaged group in terms of mean, a number of students participated, standard deviation, minimum score and maximum score, and skewnesses. And the total is the total mean of reading and total mean of math without the desegregation of disadvantaged and advantaged. So when you look at the disadvantaged here and the advantaged here, the mean score of advantaged mean is way higher than the disadvantaged. For reading and for math, the gap is even larger. You see here, and the standard deviation of disadvantaged is way much higher than the advantaged. So that means there's a larger dispersion for the disadvantaged. And also the skewnesses data, you can look at the skewnesses data here, and it's way much more positively skewed, negatively skewed for non-disadvantaged, which means the non-advantaged students have a higher peak on the higher side scores than the disadvantaged group. So you can compare 2012, 2013, and you can extract data for 2012, 2011, 2012, and compare the trend of different years as well. And then you can use this information, create your own summary table to tell your story and disseminate information with your participants. You can also create charts and figures to tell the story as well. Thank you.